Hey guys, today we're going to look at some limits that require a little more advanced algebraic manipulation in order to solve them. Up until now, we have gotten pretty comfortable with using direct substitution and factoring. So now we want to take it a step further and look at some different strategies that we can use for new or more complicated limits that direct substitution and factoring would not work for. So we're going to start off right off the bat with the difference or sum of squares and cubes. And up here at the top, I just want you to go ahead and we're going to write down the formulas for the sum and difference of cubes, just because you might not have that one memorized as readily available in your working memory. So if you have something cubed minus something else cubed, you can rewrite that difference of cubes as a minus b times a squared plus ab plus b squared. And then if you have the sum of cubes, it looks very similar, but we just have some of our operations are going to be opposite. So a plus b times a squared minus ab plus b squared. Okay, so we're going to use those two formulas for these first couple of problems. And the reason that I know I'll have to use those is because when I try to solve this limit using direct substitution, I plug in 0, I'll get 3 cubed, which is 27, minus 27 on top, which is 0, and then I'll get 0 in the denominator. So direct substitution won't work. If I try to factor, well, I can't factor using typical factoring strategies, something that's cubed. And so on that, I'm thinking, hey, I got something cubed minus something else cubed here. One kind of note to make is that if we're following this strategy, a cubed, so the a would be, I'll write it over here. So our a in this scenario would be x plus 3. And then b, careful, because b is being cubed and we get 27. So what cubed gives me 27? Well, that would be 3. And so when I rewrite it using this side of the formula, my a value is going to be x plus 3 and my b value is just going to be just the number 3. So don't mess up the fact that b here is 3 and not 27. All right, so let's go ahead and we're just going to start simplifying this the numerator of this rational expression. So I'm going to rewrite, because this is a cubed minus b cubed, so I'm going to rewrite it using this side of the formula. So our a is going to be x plus 3, and then minus our b value, which is 3, okay? And then I have a squared, so x plus 3 squared, plus 8 times b, so x plus 3 times 3. And then I have plus b squared. So b is 3, so 3 squared is 9. Okay. And then I'm just going to start trying to simplify that. Oh, I still have, don't forget about this x on the bottom that we have here. Okay. All right, so then now let's work with this. So in our first term, we got x plus 3 minus 3, and I technically don't need these parentheses right here, so I end up with just an x in front. And then in here, I'm not gonna bother doing too much simplification yet, and you'll see why in a second. So I'll still have, like, I'm not gonna FOIL out the x plus 3's squared plus, I can go ahead and distribute that 3, though that's easy enough. 3x plus 9 plus 9. All over x. And the nice part about this is when I do this, when I start to simplify the numerator, I'll notice that I have an x out front and I have an x right here, and so those x's end up canceling out. And now I'm left with just what's inside this parenthesis, this big set of parentheses. And so I just have left over x plus 3 squared plus 3x plus 18. And now the nice part is, so I have simplified this enough to the point where I don't even have a denominator anymore. So now if I go back and I actually try to find the limit of this, so remember, because that's what I'm doing all along, is finding the limit as x approaches 0. So if I try to find the limit of this simplified version now, it will be what this equals. And so now if I try to find the limit of this function as x approaches 0, I plug in 0, and I would get that just goes away completely. The 3x just goes to 0. and then this x goes to 0. So I just have 3 squared plus 18. So 9 plus 18, which gives me a lovely 27 is my final answer. Cool. Let's go ahead and do this next one. So on the top, it's a little bit tricky to notice, but this is technically, you can rewrite this as x squared minus 16, which is a perfect, a difference of squares formula. And then on the bottom again, we do have a sum of cubes formula. So I have something cubed plus something else cubed. So I'm going to go ahead and write out the simplification of this. Oh, and I'm not going to do it right next to my limit. I'm going to do it below. So up top, remember it's secretly this, so I can change this into x plus 4, x minus 4 using difference of squares. And then on the bottom, and I'll have to extend it a little bit, I have something cubed plus something else cubed. So my, in this scenario, my A would be what cubed gives me 64? Well, that's just 4. And then my B value would be x, because x cubed gives me cube. All right, so then we have A plus B, because I'm following this formula now. And then A squared, so 16. Minus a times b, so 4x plus b squared plus x squared. Lovely. And the nice part is when I do this automatically without even simplifying anything, I can see something that will cancel out, and that's the x plus 4s. And then I'm just going to check now and see if I can plug in the negative 4 into what's left over, if that will work for me. So on top, if I plug in negative 4, I'll get negative 4 minus 4, which is negative 8. And then on the bottom, I will get 16, and then it looks like plus 16 more, because negative 4 times negative 4 is a positive 16, and then plus negative 4 squared. So basically what I came to was that I'm not going to get 0 over 0, so now I can actually calculate what happens to this as I do the limit of it. So let me see. So if I do the limit as x approaches negative 4 of x minus 4 on top over 16 minus 4x plus x squared, then we'll scooch on over here just to work out what I kind of talked through up here. So on top, we'll get negative 8. And then on the bottom, I'll get 16 plus 16 plus 16. So negative 8 over, what's that, 48? Yeah. And then that reduces to negative 1, 6. Cool beans. All right, so that's how you would use difference of squares and then the difference in sum of cubes formulas. So I'm going to have you guys practice that a little bit. And now we're going to move on to what our last strategy we'll learn in this video, and that's rationalization. We learned this a little bit in Algebra 2, and then we reviewed it very briefly in pre-calc, but we were dealing with it in different scenarios or separate trig scenarios from this. So to do a rationalization strategy, so first thing you always try, plug in 25. 25 on top, 5 minus the square root of 25 would be 5 minus 5. So that's 0 on top. 25 minus 25 on the bottom is 0 on bottom. So we can't directly substitute. We can't factor because there's nothing to factor. We're having radical going on. So we use a strategy called rationalization. And when you use rationalization, what we do is we multiply by the conjugate. So I don't know if you want to make yourself a little note up here and say that this is technically how we use the strategy of the of rationalization. Multiply by the conjugate. Oh, yikes, that handwriting. You know what it says. Okay, and when we do that, what you're doing is you're going to take the expression that has the radical or the root in it, and you're going to multiply the top and the bottom by that expression, but you're going to change the middle operation. So instead of 5 minus the square root of x, it's going to be 5 plus the square root of x, and we're going to do that on the top and on the bottom. Okay, and then basically we're going to multiply it all together, foiling it out. And you'll see what happens. The whole fun point of multiplying by the conjugate, okay? So on top, we get 5 times 5, 5 times square root of x, negative square root of x times 5, and then negative square root of x times square root of x. So that comes out to be 25 plus 5 square root of x minus 5 square root of x. And then you have square root of x times square root of x, which would just cancel out your square roots. So you'd have just a minus x at the end. And then on the bottom, we're not going to FOIL yet, and you'll see why, because this fun thing happens with rationalization. Cool. All right, and so when we multiply by the conjugate, the nice part is that we will always cancel out our middle terms. And so what you're secretly left with on top is just 25 minus x. And the nice part is that you have a 25 minus x down here. So I can go ahead and my 25 minus x cancels out with this 25 minus x. So then secretly what I'm left taking the limit of is the limit as x approaches 25 of 1 over 5 plus, whoops, looks like a 6, of 5 plus the square root of x, which if I'm going to actually calculate that, plug in 25, 1 over 5 plus the square root of 25, 5 plus 5 is 10, so 1/10. Bam. And we can do the same thing over here. So if I plug in 0 right now, I get 0 over, let's see, plug in 0 here, square root of 12 minus square root of 12 is 0 in the bottom, so 0 over 0. And so I'm going to go ahead and I notice I have radical expression, a radical expression, and you can do it in the numerator or the denominator. And so I'm going to multiply by the conjugate on the top and bottom. So I got x squared plus 12 plus square root of 12 now. Notice it's just that middle operation that changes. This one actually under the radical didn't change at all. And then same thing on the bottom. Cool. And then technically what you're doing is you are foiling the part that you're using as your conjugate. And once you get really good at these, I'm not even going to end up writing the middle terms or caring about the middle terms because they're always canceling out. That's the whole point of multiplying by the conjugate. So I'm just going to multiply the first terms together. So the x squared plus 12, the square root, with this one. So your square roots will cancel. So really you're just left with x squared plus 12. And then your last terms together because your middle terms would always cancel out. So I'd have square root of 12 times square root of 12. One of them's negative. So you'd end up, the square roots would cancel again. And you'd end up with just minus 12. Okay. And then that's supposed to be on the bottom. So let's show what that simplifies to then automatically. So, actually, no, what? I'm going to write it so it's all nice and neat. I just don't believe in editing videos, you guys. It's fine. All right, we're going to find the limit after this part. So on top, we don't FOIL anything. Because usually something fun happens. And then on the bottom, like I said, when we multiplied your first together, you just ended up with x squared plus 12. And then your last together, you just had minus 12. So nice parts. Your 12s automatically cancel out there. And then your x squareds can cancel out. And so then really what you're trying to find the limit of is just the square root of x squared plus 12 plus the square root of 12. And if I plug in 0, I get square root of 12 plus square root of 12, which is 2 square roots of 12. Or if you want to get really fancy, I believe that is 4 square roots of 3. There you go. Let me know if you have any questions on these two types of problems. And so feel free to take a break before you watch the next section, or if you want to go do some of these problems first, that would be fine as well. All right. Thanks, guys.